Question number 3. The horizontal position measured in meters of a particle is given by this function, x of t equals t squared e to the minus 2t. This is position. It's telling us its position. The derivative of position is velocity. So I need to take the derivative of this function. The derivative of x of t, I can just write dx dt, is equal to, well, we have again the product of two functions. So let's make a line here and say f g prime, the derivative of those two functions, is equal to, I usually say f prime g plus g prime f. That's how I remember it because the quotient rule, which we're not learning in this class, has this same form. First thing I need to do is say f equals t squared. F prime is equal to 2t. G is equal to e to the minus 2t. G prime is equal to minus 2e to the minus 2t. I'm using my derivative rules from the right-hand side. Now I can put it all back here. So I have f prime. F prime is 2t times g. G is e to the minus 2t. Plus g prime. Actually, that's going to turn into a negative. So minus 2e to the minus 2t, that's g prime, times f. F is t squared. I can rewrite this as, actually, I'm going to factor a bunch of things out of here. I have 2t e to the minus 2t. My first term I have completely there, so I just get a 1 minus my second term. Well, I have a 2, I factored out a 2, I factored out the e to the minus 2t, and I factored out 1t, so I'm left with that as my derivative. And it's always nice to factor things. You're going to see why shortly. This is the velocity, which is the derivative of position. Next, it says find acceleration. Well, what's acceleration? Acceleration is the derivative of velocity. So again, I have to take the derivative of this function. And now this function has 3 things multiplied together. I think I'm gonna rearrange this. I'm gonna rearrange v of t. I'm gonna say v of t, just to make it a little easier to use the product rule. Well, I don't have to worry about my 2. It's a constant. I'm going to factor out this e to the minus 2t, and I'm going to multiply that t back into the function just for the purposes of taking the derivative. Now I have, and I'm not going to write everything, I'm going to write f is equal to e to the minus 2t. F prime is equal to minus 2e to the minus 2t. G is equal to t minus t squared, and g prime is equal to 1 minus 2t. Now I have everything I need. So v of t is equal to 2. I just took the constant out. I did this. It's a constant times that function, and that function is built with two different functions. So I have 2 times f prime. F prime is minus 2e to the minus 2t times g, which is t minus t squared, plus g prime, 1 minus 2t f e to the minus 2t, end parentheses. This equals, let's see what I can factor here. I definitely can factor out an e to the minus 2t. So I have 2 times e to the minus 2t. I have times negative 2 times t minus t squared plus 1 minus 2t. And I already factored out that e to the minus 2t. This is equal to e to the minus 2t times minus 2t plus 2t squared plus 1 minus 2t, which equals 2e to the minus 2t times, I have 2t squared minus 4t plus 1. And that is definitely as simple as it gets. That's my acceleration. That is a of t. Now it says find critical points. I don't know if we've had that much interaction with critical points. Critical points are where the derivative is either equal to 0 or undefined. Okay, that is a critical point. You'll learn a lot about this in calculus. Well, we already took the derivative of our function. It's our velocity. Let's go get our derivative. Here we have it. Now you'll see why this form is the form that you'll prefer. Here's my derivative, and what I want to do is say I need to let v of t equal 0. I get 2 times t times e to the minus 2t times 1 minus t. Well, I have lots of things multiplied together, so let's take them all separate. This is true when 0 equals 2. Well, that's never, so I don't have to worry about that. T equals 0. That's good. E to the minus 2t, never. This never equals 0. It has an asymptote e to the t looks like this, and e to the negative t would look like this. But there is an asymptote on this line right here. Those two lines never touch zero. Therefore, e to the minus 2t is never equal to zero. And then one last chance, 1 minus t equals 0. That works. T equals 1. There's my two solutions. My critical points are when t equals 0 and t equals 1. Now it says use the second derivative test to classify each critical point as corresponding to a relative max or min. Again, something we didn't talk about. I know what the second derivative is. I'm just going to write this as x of t double prime equals. Basically, what we want to know is what value that equals. If x of t double prime, the second derivative, is greater than 0, then think of it like this. If you have a parabola that has a positive coefficient, it's opening up and we have a minimum value. So if the second derivative is greater than 0, then we have a local or relative, they mean the same thing, minimum. If x of t, the second derivative, is less than 0, then we have a negative value, which means think about it like a parabola opening down, and we have this maximum value. Then we have a local or relative maximum. I'm going to open this full screen now because we don't need that other side. And we're just going to plug in 0 first. When t equals 0, my second derivative, and I'm picking these numbers from here. These are my critical points. These are where the relative max and relative mins occur. We're going to find out if we can figure out which is which. So I plug in 0 into this function, and I get 2e to the 0 times t is 0. That's going to be the first term is going to be 0. The second term is going to be 0. The third term is going to be 1. This is the same as 2. Anything to the 0 power is 1 times 1. My answer is 2. Since it's positive, this is a relative minimum. When t equals 1, I have 2e to the negative 2 times 1. Times 2 minus 4 plus 1. I'm still plugging my values into this function. This equals 2 over e squared times 2 minus 4 minus 2 plus 1 minus 1, which equals negative 2 over e squared. That means we have something that looks, since it has the negative, think of it like a parabola opening down, and I have a relative maximum at t equals 1, which is, that's it. I have, there's not, let me state that again. I have, all this tells me is that I have a relative maximum at t equals 1. And that's all it's asking. Use the second derivative test to classify each critical point as corresponding to a relative maximum, positive, a minimum.